Good day. In today's lesson, we're going to talk about identifying appropriate test statistics involving population proportion. In this lesson, this is all the things that you need to do. As you may recall, the central limit theorem tells that if the sample size is sufficiently large, then the mean of the random sample from population is a sampling distribution that is approximately normal. Even when the original population is not normally distributed, this means that regardless of the shape of the original distribution, the sampling distribution of the mean approaches a normal distribution as long as the sample is large enough. Remember that the central limit theorem is not limited to a sample means only. It can also be applied to sample proportions. This module deals on identifying the appropriate form of test statistics involving population proportion when the central limit theorem is to be used. However, the activities are limited to estimating the population proportion and sample proportion as preparation in solving for the appropriate test statistics. As we're going through this module, we are expected to 1. Define population proportion and sample proportion. 2. Determine the value of the population proportion and sample proportion. 3. Identify the appropriate form of the test statistics when the central limit theorem is to be used. And 4. Relate population proportion in real-life situation. So there are certain situations when the data to be analyzed involve population proportion or percentage. The following are some of the examples that show this condition. And a politician wants to know the percentage of his constituents who approve his policy on educational programs and reforms. A manufacturing company is interested in determining the proportions of defective products in the assembly line. A set of randomly selected employees were asked to determine the percentage of their income spent on food per month. In a sample of 50 students, there are 15 part-time timers. This situation shows proportion. 50% of the restaurants in the sample generate more than a third of their weekly sales of juice. It is noticeable that the cases above use percentage of the population. In the previous modules, you have learned how to test the hypothesis concerning population mean and sample mean. But this time, you will learn how to test hypothesis involving population portion to be able to do the z-test statistics for population portion will be applied particularly when the central limit theorem is to be used. However, as I mentioned before, this lesson will just serve as a preparation. Further details on the computing for the test statistics involving portion will be discussed on Module 12. Go over the lessons and have fun working with activities. Next, dealing with various problems or situations oftentimes leads to confusion. In this section, take note that problems involving proportions, unlike in population mean and sample mean, never use terms such as average and mean, but percentage instead. So we should never use the terms average and mean, but percentage. Let us first define that what population proportion is. So population proportion and sample proportion. Population proportion, P, is a part of population with a particular attribute or trait expressed as fraction, decimal, or percentage of the whole population. In this symbol, P is equals to number of members in the population with a particular attribute over number of members in the population. And P is equals to blank percent. Now, notice that in Marapat City, 10% percentage is used of the entire residents as senior citizens. Therefore, the percentage of the senior citizen residents represents the population proportion or percentage, which makes P is equals to 10% in decimal form 0.10. Similarly, among these senior citizens, what percentage owns a cell phone? That illustrates the sample proportion in symbol P hat, which is read as P hat, which is computed as follows. P hat is equals to number of senior citizens residents with cell phones over number of senior citizens residents. So substitute P hat is equals to 421 over 500, and that equals to 0.84. Sometimes the sample proportion is stated directly, such as 20% of the respondents is equals to 0.20, 5% of the defective bulbs is equals to 0.05 rather. 50% of the grade 12 students is equals to 0.50. Note, to exchange percent to decimals, see examples below as follows. 12% converted to 0.12% as 12.12. 5% converted to 0.052. And 12.5% is converted to 0.125. On the other hand, there are cases where we will need to calculate p-hat examples of these kinds. Examples of these kinds are 70 out of 200 residents are married, 150 out of 500 listeners are interviewed, 10 out of 1,000 bulbs are defective. In this case, we need to solve for the value of sample proportion read as p-hat. Sample proportion is the ratio of number of elements in the sample processing the characteristics of interest over the number of elements in the sample, or n. It is computed by the formula p-hat is equals to random variable for the number of success in n samples over number of trials for the size of sample is equals to x over m. P-hat is equals to x, where p-hat is the proportion of number of success in n samples and read as p-hat. X represents the number of successes in n samples and n represents the size of the sample. The example below will help you understand better how we can easily estimate the value of sample proportion. Remember that in this situation describing a population proportion, sample proportion rather, the words mean or average are not used. So it is stated above that the words mean or average is not used in identifying, rather percentage is used. Illustrative examples. For a class project, a grade 12 STEM students wants to estimate the percentage of students in his school who are registered voters. From 45% of the grade 12 students, he surveys 500 students and finds that 200 are registered voters. Determine the value of P and compute for the sample proportion. Now, here is the solution. The population proportion is rate of 4% used from the entire grade 12 student. Therefore, population proportion is P is equals to 45%, and if converted to decimals is equals to 0.45. To find the sample proportion p-hat, identify the following. Survey grade 12 students. N is equals to 500. Registered grade 12 students is equals to x equals to 200. Therefore, the sample proportion will be computed as follows. Sample proportion p hat is equals to number of registered grade 12 students over number of grade 12 students. Now substitute the number 200 and 500. Then you will get 0.4. So this is the things that using the central limit theorem in testing population proportion. When testing situations involving proportion as percentage or a probability, the following assumptions must be considered. The conditions for binomial experiment are met. There is a fixed number of independent trials with constant probabilities in each trial, as two outcomes that we usually classify as success or P and failure as Q. The sum of P and Q is 1, hence we can write P plus 1, P plus Q rather is equals to 1, or Q is equals to 1 minus P. The condition NP is greater than or equal to 5 and NQ is also greater than or equal to 5 are both satisfied so that the binomial distribution of sample proportion can be approximated by a normal distribution with mu is equals to NP and standard deviation is equals to the square root of NPQ. However, the specific number varies from source to source. Some authors are use 10 instead of 5 depending on how good an approximation one wants. Likewise, the second assumptions serve as the basis to determine whether the sample size from the population proportion is sufficiently large or not. And remember this, that this time, the condition that sample be large is not n, to be at least 30, but it should satisfy the second assumption. For large size of sample proportions, the central limit theorem, or CLT, can be used. Bear in mind that if the sample size is sufficiently large, then the mean of the random sample from a population has a sampling distribution that is approximately normal, even when the original distribution is normally distributed and n is greater than or equal to 30. Now let us check the assumptions from the previous equation. It is evident that the responses have only two outcomes: registered voter success or not registered voter failure. Therefore, the first assumption is met. 2. To be able to satisfy the second condition, we find the hypothesized value of the population proportion P is equal to 0.45, while N is 500. To get Q is equals to 1 minus P, which makes Q is equals to 1. Substitute P to 0.45, then it equals to 0.55. Through substitution, it shows that the second assumption is also met, since 500 NP greater than or equal to 5 times NP and NQ is equals to greater than or equal to 5. 500 times 0.45 is greater than or equal to, and 500 times 0.5 is equals to or greater than 5.
Report ka?
Oh.
Ano? Voice record na?
Oh. Since we have shown that NP greater than 5 and NQ is greater than 5 or equal to, all conditions are met where the sample size is truly large enough to use CLT. In this condition, the test statistics to be used is the z-test statistics for proportion denoted by z-com or the computed z-value. The z-test statistics for population proportion, recall that z-score formula to be z is equals to sample mean minus population mean over sub and over standard deviation, with the NP greater than or equal to 5 and NQ greater than or equal to 5, and with the standard deviation of sample portion be substituting be ay the standard deviation of sample proportion would be square root of PQ over N. Now it is substituting and equals to and it is equals to the square root of PQ over N for standard deviation subsample mean. Therefore, the formula for the value z test statistics for population proportion would be z computed value is equals to p hat minus p over the square root of pq over n. Or you can use z computed value is equals to p hat minus p over the square root of p times 1 minus p over n, where z computed is the z test statistics proportion, p hat is the sample proportion or x over n, p is the hypothesized value of the proportion population proportion, whether is the sample size or the number of observations in the sample. Q is equal to 1 minus p. Remember this formula as we are going to use this in module 2. The actual computation for the test statistics involving population proportion will be held. And that is all for today. Thank you for listening.
So, lesson 1 sa module 11. So, identifying appropriate rejection region involving population proportion. One part in testing hypothesis is determining if the results of a theory or the hypothesis from the experiment is probably true or statistically significant. To be able to do this, the rejection region or critical region will be employed. Every rejection region can be drawn on a probability distribution. Its image can be done using normal curve. It can either be one-tailed or two-tailed rejection region. More specifically, one-tailed rejection region can be left-tailed or right-tailed. Now, how can we determine the rejection regions? Let us find out. So what is it? There are two ways to test the hypothesis, with a p-value approach and with a critical value approach. Here we will consider the rejection region with a critical value approach. The critical value enables us to reject or not the null hypothesis. Also, it is calculated through alpha levels and symbolized by z or z tab. So, kani ako rang i-move on siya akong explanation ani. So pagkita nimo dira sa curve kanang naay mo graph diha, naay part ana sa left side mo na siya gi-shade. So kana na part gitawag na siya og kuan kanang critical region or kuan rejection region. Well, ang kanang walay shade, kanang dako na walay shade mo na siya gitawag og acceptance region or non-rejection region. So ang critical value ana kay mo na siya ang mag-separate sa rejection region from the acceptance region. So, then derived from the level of significance and expressed as the standard z value symbolized as z tab or z tabular. We can use the table of critical values for the commonly used levels of significance presented in the previous slide. So dire makita nimo kung ang level of significance din unsa sila na test type. Sa left-tailed test kay makabutan na siya mga less than or naay negative. Sa right-tailed test kay positive lang siya din. Sa two-tailed test kay positive negative din. Next niya kay number. So level of significance muna siya the degree of significance in which we reject or do not reject the null hypothesis. So ang level of significance kay mo na siya ang basis sa critical region or sa the rejection region dictated by the alternative hypothesis. Then kaning sa ubos ani, the following are common values of statistical significance. Basta 0.1 muna siya highly significant. Basta 0.5 muna siya statistically significant. While ang 0.10 muna siya significant yun. So ang rejection region is kay 0.5 or 5%. So muna siya ang rejection region. So unsa man ang rejection region? So ang rejection region muna siya the range of values of the test value which indicates that there is a significant difference and that the null hypothesis should be rejected. So sa Bisaya pa na ay dako na kausaban, then muna imong maunang i-reject nimo ang null hypothesis, then i-accept nimo ang alternative hypothesis kay naa man siya dako na kausaban. While ang non-rejection region kay the range of the values of the test value which indicates that the difference was statistically insignificant and that we failed to reject the null hypothesis. So kani kay vice versa ra pasabot wala ra siya changes, so kani kay kuan ra i-accept ni ay i-reject ang alternative while i-accept nila ang null hypothesis. So sunod kay na example rin is just illustrative sample 1. A sample of 100 students is randomly selected from Pinagpala High School and 18 of them said they are left-handed. Test hypothesis that less than 20% of the students are left-handed by using 0.5 as the level of significance. So, dara tay examples there. So, what to do? Identify the level of significance. When number 1 himuon. So, sunod kay formulate the alternative hypothesis. Ikatulo kay determine the critical value or z-tab. Illustrate the rejection region in the normal curve. So, ato ning try og solve. So, dire na solution daan. So, ang given naman dito ang level of significance which is 0.5 or 5%. Then, ang alternative hypothesis niya kay naa siya sa 0.20. So, kay naaman siya less than, pasabot ani, muna siya ikuan, left-tailed kay less than man. So, to determine the critical value using the table, we consider the intersection of the row for the left-tailed test and column for 0.5. Hence, the table tells us that the critical value is 1.645. Negative ni siya, kay left-tailed man. So, muna ang ang illustration it under the dire sa solution nadre ang illustration. So, as makita ninyo naa sa left ang critical value kay left-tailed test man siya, so negative na po siya less than, so ang critical region ana naa sa left side. So sa ubos ana na illustration kung asa dapat ang critical value, so mo lagi na illustration. Pero kaning sunod ani na step kay magdetermine ka kung ang ang null hypothesis ba kay reject or accept nimo. So di man ako ang part, so more on module 13 man na, so akong group mates na mo explain about ana. So thank you Morto.